Hello, welcome to the new session of the electronics. Today we are discussing about the pulse radar system. So, in the pulse radar system, it has the transmitter, receiver, and the duplexer antenna. And the block diagram of pulse radar system is this. In this figure, this is the transmitter, and the transmitter section has trigger source, modulator, output tube, ATR switch, TR switch, and this is the receiver part of the pulse radar system, and it has local oscillator, mixer, IF amplifier, detector, video amplifier, indicator. This is the receiver section of the pulse radar system. So let us see the function of the pulse radar system. First of all, this is the trigger source, and the function of this source is to produce the pulses, and that pulses is given to the modulator, and the modulator provides the rectangular pulse voltage, and which can be used as a supply voltage for the output tube. And that voltage in the form of the pulses, therefore it can be switched on and switch off as required. Therefore, such types of the voltage is given to the output tube, and this output tube is nothing but a Megatron oscillator, or it may be the multi-cavity klystron amplifier, and the function of Megatron or klystron is to produce the high frequency microwaves, and therefore we can say that this is the source of microwaves. Therefore the microwaves are produced by this klystron, and the transmitter part of this radar, when this output tube produce the microwave and feed it to the ATR switch, then the transmitter part of the radar is terminated with the help of duplexer, which allows the high power output pulses to the antenna. This is the antenna. Okay, and therefore when the pulses are transmitted by the transmitter, then this switch automatically disconnect the transmitter part from the antenna, and it connect the receiver part or the receiver section to the antenna. And as the receiver section is connected to this antenna, then the receiver section consists of the local oscillator, mixer, IF amplifier, detector, video amplifier, and indicator. So let us see the working of the receiver. As this is the local oscillator, and the function of local oscillator is to produce the high frequency, and this mixer having the two input, one input from the antenna, or one of the signals, that is the high frequency signal or reflected signal, comes from the antenna, and another frequency that is produced by the local oscillator is also provided to the mixer, and this mixer is a crystal diode, and this mixer having low noise figure, but it has some conversion losses. Therefore, sometimes RF amplifier can also be used, which is mostly low noise traveling tube, and that is also used after the mixer. And a better noise figure for receiver section is achieved by using the extra bulb and complexity. Sometimes traveling wave tube has also used, and it has advantages of saturating large signals, and therefore it works as the limiter, which prevents the burning of crystal diode as a result of the strong echoes which comes from the antenna. Now, this mixer produces the particular frequency, that is the intermediate frequency, and that output of the mixer is provided to this IF amplifier, and the frequency which is produced by this mixer is nearly equals to the 30 to 60 megahertz, and therefore this IF amplifier operates at that frequency, that is the 30 or 60 megahertz. If the crystal diode or the crystal mixer is the first stage IF amplifier, therefore IF amplifier should be the low noise device, and it ensures that the overall noise figures of the receiver does not deteriorate the great extent. To limit the noise, another of source of noise in the receiver section of the radar is local oscillator, which for the microwave receiver and is more generally the reflex klystron, which is a noisy device with low frequency. In order to reduce the noises due to the reflex klystron oscillator, it is necessary to connect the narrow band filter between local oscillator and the mixer to reduce the noise band width of the oscillator. But in case of receiver employing automatic frequency controller, this arrangement is not satisfactory, but it balances the mixer is used instead. The automatic frequency control is used in the receiver section. It may be simply consist of the phase discriminator, which takes the part of the output from the IF amplifier and produces the DC correcting voltage if intermediate frequency changes, and this voltage is then applied to the repeller of the klystron. The IF amplifier is made broadband to allow the fairly low narrow pulses. This means the number of cascaded IF amplifier is used in this radio receiver. All these IF amplifier are either the synchronized, means all tuned at the same frequency. Overall response is achieved by overlapping the response of the individual amplifier. Then this IF amplifier gives the signals to the detector, and the function of detector is to detect the signal which is coming from the antenna, and then it is provided to the video amplifier, and video amplifier will amplify the video signal which is coming from the detector, and finally it is given to the indicator, and indicator will indicate the position of the target. In this way, here the display unit may be the cathode ray tube or the monitor, and which can display the information about the target. In this way, this receiver, that is the pulse radio receiver, works. This is the very simple radio receiver. Thank you. Thank you for watching this video.